This is part 2 of electron configurations and electron dot diagrams, starting with question number 5. When we find these elements, sodium needs to start at hydrogen. This starts to get pretty old pretty fast because we're going to be writing a lot of S's and P's and all these numbers. So there's a way to do this in shorthand. It's called the noble gas shorthand or noble gas configurations. To do that, you find your element and you go all the way over to the end. Up one row, all the way over to the end. Up one row, all the way to the end. Had it been manganese, we go up one row, imaginary row, all the way to the end. We're choosing the previous noble gas. Manganese has an atomic number 25. The next noble gas that's closest is argon, because it has a number less than 25 and it's a greater number than neon's 10. So sodium, upper row, all the way to the end, we choose neon. When we write this down in our noble gas configuration, we're going to start out by writing brackets, neon, and then we're starting a neon square. So if we're starting a neon square, we would write down neon, back and to the left, 3s1, and that's our configuration. So this is what we would write down, neon 3s1. We would circle the 3s1 because that's our highest. If we were to write the full thing, it'd be 1s2, 2s2, 2p6, 3s1. This doesn't change our dot diagram. We're still going to write sodium. We circled 3s1, one dot to the right. For phosphorus, we would choose our noble gas would be neon as well. There's phosphorus up one row to the right, neon. So our answer would be bracket, neon. Start a neon square, back and to the left, 3s1 and 2. That's magnesium square. All the way to the right, again, we're not dipping down, just straight across to the right, 3p, 1, 2, 3. When we are circling our valence electrons, 3s, 3p, 3 and 3 are our highest. Phosphorus has 2 s electrons on the right, has 3p electrons, so that's the bottom, the left, the top, remembering to share because that's polite. Chlorine, we would go up a row, choose neon again, so bracket, neon, back and to the left, 3s2, that's magnesium square, cross the road, 3p, 1, 2, 3, 4, 5. Circle our valence electrons, 3s and 3p, those are the highest, so chlorine's dot diagram would be Cl, 2s electrons, it says 5p electrons, so bottom, left, top, bottom, left. There's 5. Notice that these dot diagrams are showing the valence electrons of each of these atoms. Potassium, go up a row all the way to the right. We would choose argon this time. Argon square, that's what the brackets mean. Argon square, so we're starting argon square. Back and to the left, down the row, 4s1, and we're at potassium square. 4 is the highest energy level, so circle that. And write a K, 1 s electron dot. If we were to write out argon or potassium's entire electron configuration, it would go like so: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. We would circle 4s1 because that's the highest. And as you can see, this noble gas shorthand definitely saves us some time. Okay, moving on to the next problem. We have scandium. which is right here. So choose a noble gas, upper row, all the way to the end, argon. We're starting argon square, back and to the left, potassium square, 4s1 and 2. And if we read this carefully, right next to scandium, it says 3, 3d1. Now, as far as circling electrons here, 4 is bigger than 3, so we're going to circle the 4s2 orbital and electrons. When we do our dot diagram, 4s2, we only have spaces for what we circle, the s and the p electrons. We will never draw d dots. You should never be drawing more than 8 around the symbol. Chromium, upper row to the right, should be argon. Bracket, argon. Argon square, back and to the left, 4s2, potassium and calcium. Then 3d, count over to chromium, which is 4. 3d4. Circling electrons, 4s2, so it's circled. So we write chromium, 2s electrons, 2 dots on the right. Here are the last few electron configurations. And you can see the last few dot diagrams. Right, a few more. Do iron, then I'm going to start going a little faster. Iron's right here. To choose a noble gas, up one row to the end, argon. Back to the left, potassium and calcium, 4s2. To the right, it says 3, so 3d, iron is 6. Iron symbol, Fe, 2s electrons on the right. So this is what we get. Moving forward to copper. Copper, if we go up a row to the right, we would choose argon, followed by 4s2, 3d, copper is in 9. Circle the 4 because the 4 is bigger than 3. Dot diagram would be a Cu, 2 dots on the right. Gallium is our next one. Gallium's noble gas would be argon, because we go up a row to the end, we'd find argon. 4s2. It's calcium square, go one spot further, so scandium, all the way across that until you get to zinc, 3d10. Finally, 4p1. We have energy level 4, energy level 3, energy level 4. 4 is the highest, so circle the 4, circle the 4. Notice we're not circling the 3d even though it's in between. Gallium has 2 dots for S, 1p electron. It doesn't matter if it goes bottom, left, or top, but it has to go in one of those 3 spaces. Selenium. If we choose selenium, we need to use argon as our noble gas. Then it would be 4s2 for potassium and calcium, 3d, 10, 4p, counting over 1, 2, 3, 4 till you get to selenium square. 4p4, 4s2 are the 2 valence sublevels. Selenium has 2 s electrons, and then it has 4p electrons. 1, 2, 3, 4. This 4th dot could have gone on any of those sides, it doesn't matter, top, left, or bottom. Lastly, antimony. Antimony is right here. So if we choose a noble gas upper row to the end, choose krypton. So we will write down krypton. For encrypton's box, we come back to the left, and now it says 5s2 followed by 4d 1 through 10. That'd be cadmium square. And we'd finish with 5p 1, 2, 3. Five S2 4 D 10 5 P 3. Circle the 5s2, circle the 5p3, because 5 is larger than the 4. Antimony's dot diagram would then be the 2s electrons, as we circled over here. We have 3p electrons, bottom, left, top, making sure to spread those out. Don't give one side doubles before all of them get singles.